Hi everyone, we are Team 1D. We're comprised of Nate Jordan, myself, Logan Turan, Brooke Bushy, and James Podiger, and our product is the Cold Open. So, being in a human factors class, we've talked extensively about disabilities and designing products to be inclusive for those who might have some sort of handicap. We decided to focus our design around helping those who might have dexterity issues, whether it be someone who recently had a stroke or just a senior citizen who lacks grip strength. Food is an important part in all of our lives, and anything that can help someone like this in the kitchen could be life changing. This is currently a fairly large market and contains brands like OXO Good Grips, which makes kitchenware and tools with more ergonomic designs, and even Cuisinart, which makes automatic can openers. Through our research, we discovered most people seem to use Tupperware weekly or even daily. However, for someone with impaired dexterity, just opening those tight lids might pose a problem. This is where our product, the Cold Open, comes in.
So, fresh off of my roommate's 3D printer, this is the Cold Open. It's our solution, and it's a simple tool designed to open Tupperware containers. The operation is straightforward. Simply rest the Cold Open on the container, slide it back so that the lip catches the tab, and leverage the handle down to open. This will work with most sizes and shapes of container, and importantly does not require that you replace all of your existing Tupperware. The Cold Open has an ergonomically designed handle that will fit almost all hand sizes, both large and small, and the stands prevent it from rolling off of your counter. In our production model, it would include form-fitting rubber grips, a rubber bottom stand for additional stability, and an adjustment knob for one-handed operation. The Cold Open would also be 100% dishwasher safe. The Cold Open is a cost-effective one-time purchase that will solve a novel problem for many, as few if any dedicated reusable container opening solutions exist.
We completed a task analysis in order to make the necessary improvements to our device. Some of the main topics we investigated were design principles for handheld tools and favorably translatory movements of the hand-arm system. Upon completing the task analysis, there were a few reasons for concern. We needed a better handle for our target audience to be able to use, and we needed a way to reduce the amount of force necessary to open the container. We were able to come up with some valuable solutions from the literature review. When a one-handed tool is designed, you must consider that it is typically moved in a power or pinch grip and only occasionally will require finger motion. This means that we can design our tool in a way that the whole hand can grip the handle, and we do not need to account for specific finger placement. It is also said that if a tool is being used for a high level of torque, the only true option is a power grip. In our case, there is a force and torque being exerted while trying to remove the lid from the container, meaning a power grip would be an ideal grip for our tool. Investigating the design principles for handheld tools led us to discover that our tool should have a full hand power grip in order to have the best results for our task at hand. We next investigated the favorable translatory movements of the hand-arm system. In a study, it was found that directions around 30 degrees are the most optimal for these relevant muscle groups. When the strain was tested at 90 degrees and 160 degrees, 30 degrees proved to be half as much of the strain. This finding shows that our tool will be ideal if the Tupperware is placed on a counter or table. This way, the extension of the arm does not surpass 30 degrees and will be the most comfortable angle to use our hand tool.
Using injection molding. Injection molding has a starting high fixed cost for creation of the molds, but in mass production of our product, it would end up paying off and be a relatively reasonable production method. It would be 2 steps. It would be similar to how toothbrushes are actually made. So the first step would be the base, which is made of plastic. So the molten plastic would be injected into the mold, cooled, and then popped out of the mold. Secondary step would be the grip or handle that we would be placing on our tool, and then the plastic base would be put into another mold where rubber would be molded around the top part where a handle is needed. The plastic is strong enough material in this case because leverage would be being used and not a ton of stress is put on the material, therefore plastic is definitely strong enough, and then rubber is used as the handle for a better grip and more comfortable use for users.